Today's lesson is on infinite limits and limits at infinity. When I practiced making the notes, I realized there's a lot of material here, so you're going to have 3 separate videos to watch. The first one's going to deal with infinite limits. Okay? Infinite limits deal with when x is approaching c, the y value is increasing without bound. So that's what goes right in here. A limit in which f of x increases or decreases without bound as x approaches c is called an infinite limit. Okay, infinite limits, or here's the notation, as it goes to infinity, do not exist. We just say that the limit equals infinity, so we are more accurate in describing how the limit doesn't exist. This is because a limit must be equal to a real number. All right? The answer being D and E is always acceptable, right? But sometimes on a multiple choice test, it won't be an option. Your only option will be infinity or negative infinity, and you have to decide which way the graph is going. Hopefully, we don't know yet, the AP exam will have some non-calculator part of the test. With a non-calculator, you have to be able to graph your functions to know which way it's going. All right, so let's do some examples. They want to know the vertical asymptotes, because that's what we're talking about. An infinite limit is when C is approaching an asymptote. Vertical asymptotes occur when the denominator is 0. Denominator is 0. So in this case, your denominator is going to equal 0 at x equals 1. A graph of this looks like this. Here's 1. It's got a branch over here and a branch over here. All right. This one, what makes the denominator 0? When is the sine function 0? Well, it happens at pi and all multiples of pi, so what we say is it equals pi k. And k is any integer, and so it happens at pi, 2 pi, 3 pi, 4 pi, or negative pi, negative 2 pi, negative 3 pi. This function, it kind of looks like the cosecant, but I guess it is because it's the reciprocal function, okay? And this is pi, so there's an asymptote there. All right, this last one, before you make an answer, make sure you factor it. Okay, this factors to x plus 4, x minus 2, and x plus 2, and x minus 2. We end up with a hole at 2, okay, a hole at 2, and an asymptote at negative 2. Remember, those are discontinuities. The asymptote is non-removable. The hole is removable. Something else to think about. Don't forget the lessons that we've learned already. All right, find the limits above. So what they're asking about is you would ask the limit as x goes to 1 of 1 over 2 x minus 1 is equal to, you have to say d and e in this case because when you come in from the right, it goes to positive infinity. When you come in from the left, it goes to negative infinity. Okay, part B, you're going to take the limit as x approaches pi of 2 over the sine of x, and it also does not exist because from the right it's going to negative infinity, and from the left it's going to positive infinity. Part C, the graph of this looks like this. We forgot to graph it. It has an asymptote over here at negative 2. So the limit on this case, the limit as x approaches negative 2 of f of x is equal to d and e because one's positive and one's negative infinity. If they both go to positive infinity, you can say positive infinity. They both go to negative infinity, they go to negative infinity. All right? Next one. What about this one? X approaches negative 1. It is an asymptote, or is it? What does the graph of that look like? Well, I have to admit, I cheated, got out my calculator. But if you think about it, if you plug in 2, 2 plus 1 is 3, over 3 is positive 1. So I plugged in 2 and I got 1. If I plug in 4, I get 5 over 5 and it's 1. If I plug in a half, I get 1 1/2 over 1 1/2, it's 1. Okay, and that plug in 0, you get 1 over 1. When you plug in -1, it's not defined. So this is going like that. If I go over here, -1 is still undefined. When I plug in -2, you get -1, but you're taking the absolute value over -1. It equals -1. Okay, and you're going to find that the graph goes this way. So I have a jump at -1. So the limit there is equal to dne because it's a jump and it's non-removable. Okay, something to keep in mind. All right, properties of limits. If one of them is equal to infinity and one of them equals a number, when you add them together, you still get infinity. When you multiply them together, you still get infinity. All right, whether it's, and if the L is negative, okay, that's what they're telling you here, it's going to be negative infinity, because you're multiplying a huge number by a negative. Here you've got a number divided by a huge number. What happens when the bottom of a fraction gets big? It gets closer and closer to 0. So this is 0. All right? These properties hold true for one-sided limits also. Okay, let's look at some examples. There was a mistake here. All right. If 1 over x squared goes to infinity, this is getting closer and closer to 0. So you're talking fractions. It's 1/2 squared, 1/4 squared, 1/8 squared. It gets huge. All right? And this is going to 1. So you've got 1 plus a huge number. It's going to be infinity again. All right? This one is going to 1 from the left. They tell you it approaches 2. The cotangent is going to negative infinity. I've got a 2 on top and a huge number down here, a negative huge number. Okay, so it's going to go to 0. That we do a lot of that. These are non-calculator questions. These are ones I want you to think about. What's happening to the denominator? Is it getting really big or is it getting really small? All right. The limit at infinity. This is a good question. We've changed topics. I'm going to stop now and make another video.